I'm also a maths teacher here as well. Not too long ago, I used to be a student here as well. So, yeah, it's pretty cool.
Yeah, amazingly, Usama was formerly a student, formerly did maths and further maths with us, loved it so much that he's come back to be a teacher with us now, and we're so glad to have him. Absolutely. So yeah, brilliant. Okay, so that's this. So like we said, there's your slide on summer induction. What we're going to do just now as well is, I think Semra's going to share a link with you. I'm going to stop sharing my screen so Semra can share something with you just now as well, because we're going to get started with a bit of maths, which I'm really looking forward to.
Yeah, okay, guys. I'm going to, first of all, send the link to you now. Okay, what I would like you to do is simply click on that link and put a name. Okay, so we know we can call you by your name, or you can just put up a name for now. So what I'm going to do, oh, it's very slow at the moment. I don't know if you guys can actually see me presenting.
Yes.
Brilliant. Okay, right. I'm going to start away. I've got here, so far, I've got David, Ruhan, and Akdash here. If I do pronounce your name wrong, please excuse me. What I would like you to do is put your name down so I can see many of you going forward with it already. So Maxime, Anya, Thomas, nice to see you guys there. Saihu, Abdullah, Ismail. So we're going to be doing circles today. So it's a nice introduction to circles. And I hope, with the pinch of salt, and I hope that, you have looked into a bit of circles in your GCSEs. Okay, right. Give me a little thumbs up or raise your hand, circles, if it's your favorite topic. Okay, and if you're very excited to get this started. I've got here, Tammy, Lucas, Afsa. I've got quite a few of you already. But I've got 24 here people. I think I'm going to make a start already. Okay, what I would like you to do is I would like you to start looking at the first slide there, and I want you to give me, what I want you to do is, can you see the circle there? And I want you to, I'm sure you can play around with it as well. Play around with it, and what can you see? What's going on with the circle when I move my slider? Okay, what do you see? And if you see something, obviously you can make a comment, whether that's on the chat. Okay, the greatest math teachers, the department out there will be making a comment to you. Okay, if you could give your answer on the chat, or even if you decide to give your answer on Desmos. Okay, lovely. Okay, are we seeing any comments there already?
Yeah, any comments? If you want to put any comments, chuck them in the Google Meet, and we can tell you there. I've not had any. We're just waiting for some comments just now.
Okay, right. What do we see? Actually, I'm moving my slider, and I see. Okay, what's happening with my circle? What is changing? I'm looking for those keywords as well. I'm actually going to make sure we use these keywords today. David.
Christian has said the radius of the circle changes.
Okay.
The circle becomes larger as the radius increases.
Oh, brilliant. Yeah, I like that. Okay, as radius increases, the circle here.
Words like enlargement being used. Size increases as radius increases.
Okay. Right, what about if I go to my next slide there? What do you see? So move on to your next slide, guys. Move on to your next slide. I like what I'm seeing right now. Right, what happens? Right, I am going to be moving my sliders one more time, okay? I'm going to be moving, but this time you can see I've got a function here, I've got an equation, and you may be familiar with this equation. Does anyone know what that equation is?
Oh, Thomas is straight in there. AB is the center and R is the radius, apparently.
Brilliant, Thomas.
Interesting, right? Okay, have a look. Play around with that. Is Thomas right? Is he right in saying that? If I move A and B around, will the point AB always be the center of that circle? And will R always be the radius? That's a question I want to ask just now.
Yeah. Okay.
Is that true? Is Thomas right, guys? Is Thomas right? You can tell me in the chat. Is Thomas right? Is AB always the center of this circle? And is R always the radius? Sanjiti saying, yeah, like a lot of yeses coming in here. Brilliant. Okay, brilliant. A lot of yeses. Okay, interesting. Okay, well, if you think that, then maybe we should ask you a question on the next slide. Yeah, so everybody should move themselves onto slide number 3 now, I think. If you can move yourself on to slide number 3 and try answering this question. a nice thing to say is, right, if you want to write down something squared, if you want to write down x squared, right, using your keyboard, how you want to do that is you want to use the button where you do shift and the number 6. So if I wanted to write down x squared, I'd write down x, I'd press the shift and the number 6 button, and then put a 2. That's how I'd write x squared. Shift and 6. And I can do that with Desmos as well. And you can try that out and you can see what's going on with that as well. What is the equation of this circle? That's your question. What is the equation of this circle? And you can actually type your answers in on Desmos there. Or if you want, you could even, if you're not able to get onto the Desmos activity, you can actually just type your answer into the chat even if you wanted to as well. Okay, lots of different ways you could do that.
Okay, right, I'm going to go over here and I'm going to see what people are putting in there. Oh, great, look at this, I can see already people have I'm going to look at, Anya, I'm going to have a look at yours, see if I can have a look at yours here. Okay, I'm going to see, right, we can see what Anya has put down. Okay, right, we've got here x squared plus y squared equals 3. Okay, and once you've made a comment there, you can actually see your circle being drawn. Okay, and you can see, okay, whether you were right. Okay, let's have a look. Okay, we've got here, we've got Arif. Let's have a look at yours, Arif. Right, I'm going to have a look at Arif's here. Oh, let's have a look. A little bit slow there. Oh, brilliant. Look at that. Spot on there. And I can see Arif has given me an equation here. And I can also see, okay, an explanation saying that r squared is going to be 9. Okay, so that's going to be a radius squared, isn't it? And the center being 2, 3. And it's spot on because you can see the drawing here as well. And it's got that red line, meaning it's drawn over that circle. Nicely done.
I mean, does that mean that the radius is 9?
Good question.
Does that mean that the radius is 9? Or is that different? Because that's interesting. Does that mean that is the radius 9? Oh no, you don't think so? No. Okay, so what have I got wrong here? Is the radius actually 9, or what is the radius? The radius is 3. All right, okay, so even though I've got a 9 at the end there, that means the radius is 3. Why is that? Oh, square root of 9. Oh, nice use of the square root symbol.
Yeah.
There. Well done. Radius is squared. Excellent. Right. Okay. I think we're getting somewhere. Fantastic.
Okay. When I go on to that next slide there now. Okay. Are we okay to go into the next slide?
I think so.
Yeah. Okay. What I'm seeing is now I've got circles. Okay, with a ring which has got more circles around it. What do these circles have in common? Let's think about that for a moment. Write your comment there. If you've signed into Desmos, you can write your comment there. What do these circles have in common? And if you haven't managed to get into Desmos, you can write your comment in that chat on Google Meet.
Brilliant. Yeah, a lot of people saying, is the center the same? Si, who's asking a question, is the center the same? Yeah, same center. Interesting. Fantastic. If you've answered that question on slide number 4, you can actually move yourself onto slide number 5. Because it's asking it something similar about the same thing, I think.
Yeah, and what is the center? Let's have a look at that center there. What is that center there?
Can you actually tell what the center is?
Yeah.
Maybe.
Okay. Right, so I can see people have moved on to slide 15 there. So I'm going to move on to slide 15. I've got about 17 people moving on to slide 15. Right. Once you know what it is, okay, that is similar or the same on that equation there that you saw, okay, on that circles, write an equation for a circle that follows the same pattern as the other circles.
Interesting.
Got to think about what's different as well, isn't it? Okay, what is same, what is different?
Yeah, so a lot of people are saying that they've got the same center, but I suppose, like Semra was saying, something's different about all these 6. Yeah, okay, nice one, Minashi, different radius. Okay, interesting. So each of them have got a different radius. And if we were continuing the pattern, how many ways? I mean, it's quite interesting. There might be different ways that we could continue the pattern, isn't there?
Definitely.
Very interesting.
Maxime, do you think you can give me, you put R squared there, do you think you can give me what that radius might be? Because I like what you've put there. See if you can get, yeah, see if you can give me the radius as well. See if you can come up with a radius. Ooh, Thomas. Okay, gonna have a look at this one. Okay, I'm seeing. Nicely done. Do we agree with Thomas? Well done
nice.
there.
Oh, a nice question is there another circle that you could also say would continue the pattern?
Oh.
Maybe a bigger circle.
Oh, look at that. Question, is it okay for me to show your work? I quite like this one. Look at this. Is this what you were talking about, David?
Oh, it might be actually. Yeah. Does this one also continue the pattern? I think it maybe does. Interesting. Yeah. Okay.
Yeah. Right. I'm going to move forward. Okay. Right. Trying not to leave anyone behind. I'm going to move on to slide 6 there. Okay. Now, what you have here is you've got yourself some, again, not circles going on. So what do these circles have in common now? Okay. So you see 3 circles. What do these circles have in common now? Again, make a comment, whether that's on Desmos or in the chat.
Same radius. I think there's a same radius from send duty there. Interesting. Yeah. Okay. Is there any other thing that you could say was the same about these circles? Maybe more than one thing we could say was the same.
Yeah.
Same diameter. That's quite similar to saying same radius, isn't it? It's very similar. They have the same size. Okay, right. Yeah, I get that. Okay, there's another thing which is different from the radius and the diameter that I could talk about as well, which is kind of interesting.
Abdullah, same y-axis.
Ah, I wonder what he mees by that.
Yeah.
That's interesting. Maybe you could elaborate on that a little bit, Abdullah. Yeah. Oh, I like that one from Carmen there. Do you see that one from Carmen?
Oh, yeah. Same radius, same y coordinate in the center. Oh, nicely done.
Good use of language there as well, actually. That's really good.
Same area. Okay, right. Let's move on to slide 7. Now, what you'll find in slide 7, believe it or not, is going to be write an equation for a circle. So I'm sure you've got the pattern now and you know what's going on. Write an equation for a circle, since now we're quite good at making equation of a circle, that it has the same pattern as the other circles.
Yeah, I suppose there might be a couple of different options for this one as well. Yeah. Very good. Interesting. Now, something to say about this just now is, guess what? You're not doing GCSE work anymore. Yeah? Already, we're doing an A-level lesson right now, because at GCSE, you only look at circles that have got a center at the origin, right? Now, we're extending that so we can talk about circles that have got a center anywhere you like. Very cool. Yeah. We're already learning. Welcome to A-level maths.
Yeah. Oh, I've got one from Arif. Right. Do we agree with Arif there? Does it look like that follows the pattern?
Does that follow the pattern, guys? Serenity, yes, yeah, brilliant. Okay, but is there an alternative? Is there an alternative that would continue the pattern as well? Maybe you could, I wonder if anyone else has got a different one that continues the pattern. All right, on the negative side. Yeah, interesting, Serenity, yeah. Has anyone done it on the other side? Oh, I can see one from Christian on the other side. I saw one from Christian, one from Thomas as well on the other side.
I missed that one.
Maybe I'm not right, actually. Maybe has anyone done one on the other side?
Oh, there we go.
Oh, Christian, yeah.
Yeah.
Interesting. Right. So yeah, a negative side, like Serenci's saying, yeah. So we will spot this one as well. Yeah, look at that one. We could also have x plus 7 squared plus y minus 5 squared equals 2 squared. Fab. Interesting. Okay. Okay, where are we at? We're at 18 minutes past 1 right now.
Right, I've got some things. I'm going to move on to the next slide here. We've got a scenario of Alma coming up with a solution. Okay, who's correct there?
So we're looking at slide, we're going to look at slide 8, isn't it? If we can all look at slide 8.
Alma tells Axel that she can add a 5th circle to the pattern. So think about where the 5th circle might be for the next point, 11.5, using the radius of 2 to write the equation. Okay. Here's
nice. I just had a question from Safa in the chat there, which is a really interesting one. Safa was asking, is this the beginning? As in what we do at the start of year 12 of A-level maths? Well, it is one of the first things that we'll be doing. The first things we really do, when you first come in, the first thing we'll be doing is making sure that we can get you at a level that's up to around about like 7 and above for your GCSE maths. Really, ideally, we want you at grades 7, 8, or 9, right? We will take some students on who've got a grade 6 and who are willing to put the work in, right? We will be, it is possible, we might get you to do an initial assessment if you were coming in with a 6, but we will have a chat with you about that, right? But really what we want to get you doing is getting your GCSE stuff right up to like a really good working level, like a grade 7, 8, 9, okay? After that, we'll be looking at, we'll be doing a lot of stuff on surds and indices, right? We'll look at quadratic equations, and then what we'll probably do is look at circles. But of course, I mean, if we wanted to, we could have just started off with circles, because you can see it doesn't take much and you've already extended your understanding, haven't you?
Yep.
So there you go.
Okay. I've got some great responses here. People have really given me a solid response. So I've got here, Thomas says circle should be centered at 13 and 5. Therefore, so it's going to be the equation of x minus 13 all squared plus y minus 5 all squared equals 4. Nice. Okay. Let's have a look. Going down here. Really appreciate you putting down your thoughts here. That's the most important thing, really, okay? To be able to justify your answer every time you give a solution. Okay, you're thinking about the maths. Okay, you're thinking about some of the patterns that you can see. I'm going to move on to slide 9 now. Okay, how we're doing with time there, David?
We're still, well, it's 20 past. I think we can keep going with the maths until at least half past, if not 35 minutes past.
Yep. So have a look at this here. Now, this may not be obvious one for some of us, because we've really got to be thinking about, what do these circles have in common?
This is a nice one. I'd be interested to see what sort of mathematical language we might be able to use to sort of describe this. Interesting. One more thing I wanted to say, guys, while we're on here. This is what our online lessons are like, okay? When we've been in lockdown, I don't know how your experiences have been through lockdown, but I know we've all been having a really difficult time of it, and I totally get that. We've been having a difficult time too. But we want to try and make online learning as fun and as interactive as we possibly can, right? And this is the sort of stuff we're doing all the time, right? This is how we get students really confident with their maths, sharing their answers, commenting, questioning each other, trying things out, using interactive tools. Brilliant. We're getting some answers in already as well. Oh, now Aloysius, this is interesting. A tangent can be drawn to connect all circles along the x-axis.
Right.
That's a really nice comment, isn't it? A tangent, you understand what we mean by that? A tangent can be drawn to connect all circles along the x-axis. Right, okay. Do we understand what we mean by a tangent? How could we explain what that is? A tangent. A tangent can be drawn to connect all the circles along the x-axis. Srinithius says different radius or radii, but they all touch the x-axis. Interesting. Touch it, like touching the x-axis. That's a really interesting mathematical term as well, just to touch What do we mean by that? What do we mean by a tangent? What do we mean by these graphs just touching? Actas has come back with a line which is perpendicular to the radius of a circle. That's what a tangent is.
Mm-hmm.
We're talking about a circle. That's really interesting. That's like a circle theorem, isn't it? That's like, if you've got a tangent to a circle, there'll always be a radius that's perpendicular to that tangent at the point where they meet. Very interesting. Really good. Thanks. That's interesting.
Yep. Similarly, I've got Alfie in the circle. It says in the circumference of each of the circles, there's a point with y equals 0.
Oh, really? I mean, this is really cool because there's lots of ways of saying the same thing, isn't there? I think lots of these statements are correct, but there's lots of different ways of saying the same thing, isn't there? That's interesting.
Mm-hmm. Right. I'm going to move on. How does everyone feel about that? Good?
Interesting. But yeah, I think we're picking up on the fact that all the circles they're touching the x-axis, and like the x-axis is a tangent to all those. That's really cool. Yeah.
Okay. Right. Since we know, what might be a pattern or what you can see that they have in common, write an equation for a circle that follows the same pattern as the other circles. So think about everything else that you said and see if you can actually write an equation that will follow the same pattern.
They're not really in it. I mean, this could be just any circle that is like what we were saying, isn't it? That has the x-axis as a tangent. That's a really interesting one. Let's see. I wonder how people will get on with that. That's an interesting question.
Yeah. Okay. Nice, Samia. Right, is it okay for me to have a look at? Shall we have a look at yours, Samia? Okay, quite like this one. Have a look. Ooh. What do we think?
Does that follow the pattern, guys? Does this one here, x minus 4 squared plus y minus 4 squared equals 16? Does that follow the pattern?
Okay. Right, let's pick another one there. I quite like, got one from Christian. So let's have a look at Christian. What's so nice is that, there's going to be so many different answers here. There's just going to be so many different answers, right? Look at that again.
I wonder if I wonder if it matters what we put next to the x, like x minus. I mean, does it matter what we put next to the x there? We've got x minus 0 this time. Y minus 2 squared equals 2 squared. Doesn't matter what we put with the x. Could it be x minus 0? Could we put anything else there? Interesting.
Yep.
Great. Some really good examples there.
Yeah. Right. I've got another one here. Abdullah. This looks brilliant. Look at that. Oh. Okay.
Something I noticed about this one is this has got y minus 2 squared and equals 4 there, but this, it says x plus 4. Someone else had x minus 0.
Yeah.
Yeah. Does it matter? Yeah, I mean, I'd like to ask a question. Anyone can put this in the comments. Does it matter what I put next to the x? Like, can I say x plus, I've got an x plus 4 and x plus 0. Right, or does it? Okay, you don't think it matters, Abdullah. Okay, I mean, is there a connection between any of these numbers that are up here? Are there any? Oh, great, Christian. Yeah, is there a connection between any of the numbers? So you're saying it doesn't matter what's happening with the x one, but maybe we need to concentrate on something else. Okay, so they all meet the x-axis. How do you make sure that they meet the x-axis? How do you make sure? Could you explain to somebody how you'd make sure? Because you've given an example, and I think that's great, but how would you tell somebody, here's how you do it? Because we've got some, okay. If the center, Thomas has said, if the center is AB, then B squared should equal R squared. The y coordinate has to be the radius, says Christian. As long as the y value is plus or minus the square root of the diameter. Is that right, Abdullah? That's interesting. I like that one as well. Is Abdullah right there? You're really onto the right idea. All right, Sammy is saying that B should equal R. Interesting.
Oh gosh.
Interesting.
That's really good thinking there. Really, really intense thinking now.
Loving that. This is what maths is all about, isn't it? This is great. Just spotting all these little patterns, seeing how things work together. Great.
Okay. Right. I think I'm going to go for one more. I've got so many here.
Will we do the patterns?
Yeah.
Oh, yes. I like the patterns.
Okay. Before that, we've I don't know, do we have time for that? Which of these equations could be pattern 4? So which of these equations will follow this previous pattern that we saw?
Ah, yeah. That's an interesting one, isn't it? Because we were kind of like, I think a lot of us were like answering that already, wasn't it? We did a lot of thinking about this question already, and a couple of you have given me some sort of ideas about that. That's really interesting.
Okay, and it will be, you know, if you're sitting on a laptop, you know, it would be even quite nice to even just draw some of these circles for yourself and see what's going on. Okay, so we go for, what do you think of the first option? Should we take that one off?
Let's see what people are saying in the chat. Yes, Christian said a lot of yeses coming up there. A lot of yeses.
All right, take that one. Second one. Did anyone try look at the second one?
Second one got a lot of yeses coming up there as well. Second one as well.
Cool. Okay. Third one.
No. Why not? Why not for the third one? Why not? Nope from Christian. I like that. Why not for the third one? How come the third one doesn't match? B is not equal to R. Sammy is using the same hypothesis that she used before. B is not equal to R, so it's not going to work. I think that's a good. Yeah.
That's reasonable.
I like that.
Next one then. What about number 4?
No worries, Christian. What about the fourth one? Yeah, interesting. Is 4 okay? Christian says yes. A lot of people saying yes for that one. I think I think it's following. Is that following what we thought? Yeah. Okay. Great. Okay. And how about the last one? Tell me something interesting about the last one. Can someone tell me something interesting about the last one? It doesn't follow the pattern. It doesn't follow the pattern, but you could tell me something interesting about the last one. So tell me something interesting about the last example. It's not tangent to the x-axis, is it? What could you say? Nice, Christian. Nice. Tangent to the y-axis. Y-axis is a tangent. Nice one, Elizabeth. Yes. Nice one, Afsa. Brilliant. Right, good. I think we're getting somewhere. Amazing. Nice one, Vinny. Amazing.
This is good teamwork right now. Okay. Really, really good. And I'm moving on to the next one here. Now, what you see in front of you, okay, so this is a little sketches of these circles. And what we need to do is we need to be finding these equations of these circles. It says here, okay, make it colorful, use inequalities, colorful with the American spelling there. Okay, hint, use inequalities. And you'll notice that if you do the inequalities, you might even get to shade. It's a nice pattern. Okay, I'm going to actually make this zoom out so you can see it. There we go. Right, see if you can find what the equation of these circles are. Okay, I can already see if quite a few people already had an early start to this. So I'm going to see how people are actually doing it right away, because I know a few people already started on this. Thomas, I can see you've already had a good start on this.
Nice one. Thomas, I don't know if you could like sort of continue this pattern in some sort of way or other as well with some different colours. It might be an idea. That's a kind of interesting idea. I don't know how you could sort of, there might be ways to continue this a little bit. do something a little bit more complicated, perhaps. Oh, Christian, I like the Christian said that had a quadratic curve on it for a minute. Okay. Oh, people have given this a really good go.
Yeah.
Interesting, Tom. You know, and I think people are understanding what we mean by inequalities. When we're talking about an inequality, what we're meaning is, it's like, no, this is quite an interesting thing, actually, I suppose, because we could talk about, if I was writing down an equation like x squared plus y squared is less than 1. If I wrote down that equation, x squared plus y squared is less than 1, what would that look like? What would that look like? X squared plus y squared is less than 1. How could you describe what that would look like? Interesting. Oh, lots of amazing colours going on here. I'm getting some amazing colours. Loving it. Fantastic. Right. Oh, great work, guys. Absolutely brilliant. Would you like to show somebody's work up on the screen, Sam? That would be quite nice.
I'm even starting to thinking about now. I mean, when you're thinking about making these equations, again, you've got to start thinking about what is the same and what is different about these equations, and what is the same. So you have to do less work then, isn't it? If you know what's going to be the same here. Right. I look at Thomas's work here. Now think about what is the same for Thomas's work. And Thomas, I can see you use inequalities here to make sure that it's nice and colorful. Loving this design.
Yeah, radius is 2. People are saying something the same. Radius is 2. All of them have got the same radius.
Yeah. David, I've decided. Guess what?
What?
Okay. Circles are my favorite shapes.
Circles are really cool. Circles are really cool. I don't know what my favorite shape is. I quite like a torus. I'm a big fan of a torus. Does anyone know what a torus is? A torus is a shape that looks like a donut. And I know it's making me hungry already. Toruses are very cool. They're like a 3D shape. They're really interesting. Interesting what you can do with a torus. You can take to make a torus, you start with a circle and make that circle go in a circle. Right, okay. Fantastic. Right. I think that's us done for the maths. I mean, if you want to keep playing, loads of people have got some amazing colours and amazing designs up there. I also really like the ones that are just using the equations. For example, Actas is there. It's really nice with the colours as well. Absolutely brilliant, guys. Really amazing work. What we want to do now, because the session runs until 45 minutes past, I want to remind you that we've got some current students on. We've also got, we've got Usama as well, who used to be a student here a few years ago and is now teaching with us here. Really knows us well here, but if you've got any questions for us as teachers or for any of the students, we'd like to just hear from you now, if you've got any questions at all. Of course, if you just want to keep playing around with that stuff, that's fine, but if you've got any questions, chuck them in the chat. We're here to help you. We're here to answer anything that you've got. Can even be a maths question.
Yeah.
It can be a question about what it's like at New Vic. It can be I like Ismail's. I like Ismail's there just now. Ismail's done an interesting one because he must have done a different sort of inequality. Great question, Sinjuti. What's it like at New Vic? Well, what's it like at New Vic? Well, I can tell you what it's like inside a maths classroom because I'm actually in a maths classroom just now. You might be able to see all around you here. I don't know if you can see. Maybe you can see, but you might notice all these walls are white. All these walls are whiteboards. A lot of what we do when we have you in class, a lot of what we do is get you all up as a class, working on your own bit of whiteboard on your own, like as if you're like the teacher standing at the front, but you've got your own little bit. It's a way that you can go around the room, collaborate with each other, really get interactive with each other. Under which board are we going to do maths and further maths? Well, that would be AQA. AQA is the exam board that we use here at New Vic. Is it more independent compared to secondary school? Saying duty? Yeah, I think what you mean by that is like, do you have time on your own for like for study and everything like that? Yes, you do. It's like what you've got to think of your college's experience as being like the transition between you being at school, where you've got like every single hour of every day is set out for you, to be in a university where it's like you're absolutely on your own. In between that, you've got college, where you've still got a lot of lessons you need to go to. There's still a lot of things you need to do. We're still providing a lot of support for you, but there's also going to be a certain amount of independence there, right? And I think that's, a lot of students really thrive on that. Right, okay, maybe someone else is wanting to answer some of the other questions. What else have we got? How different is further maths A-level? What will be covered in the syllabus? Anybody want to answer that one? How different? Well, what I'd say is, further maths is a little bit different. Anybody want to jump on and talk about further maths at all?
Well, if the individual is interested in further maths, it's an opportunity to delve in depth into some topics which are not normally covered in the maths A-level syllabus. I mean, if you are interested, if you've got a very curious mind, it's an opportunity for you to investigate further. And because of the limited time we have within the maths syllabus, we will not be able to cover certain topics which are not included in the A-level maths syllabus. So yes, it's challenging a bit further, as the word further maths implies, but it's also quite interesting. It offers opportunity for you to delve in detail into topics which otherwise would not be covered in the A-level syllabus.
And it also gives you an advantage when you're going to university, because all the stuff you are doing in further maths kind of like are introductory topics to what you'll be doing if you're studying maths at university.
And not just maths, actually, anything really that's mathematical related. If you were doing an engineering degree, it's going to be you're straight into what happens basically in further maths A-level. If you're doing like a physics degree, they're going to be getting you doing all sorts of things related to what you did at further maths A-level, for example, right? I've got a really good question from Coco here. I want to do maths at uni. Guess what? I did maths at uni and it was amazing. I highly recommend it. It's amazing. It expands your mind. I mean, you could say that about so many courses, but I absolutely loved it, right? So is it worth me picking all three, maths, further maths and statistics? I'd probably say, do you know what I'd say to that? I would say doing maths and further maths would probably be enough there, because there's quite a bit of statistics. Each one of those, maths and further maths, also covers a bit of statistics, right? Doing statistics on top of that might be a bit too much, right? What I would suggest is broadening your sort of like spectrum a little bit and maybe doing something else that you're really interested in. There's lots of other options out there. I wouldn't maybe suggest doing all three of those. T is asking, how much homework do we get per week? Well, there is quite a lot of homework. I mean, homework is all about getting you, I mean, at the end of the day, right? The exam board, they don't care how much homework you've done, right? They want to know how prepared you are for the exam. Every piece of homework that you're given is getting you prepped for the exam. You will be set weekly homework, right? The homework that we set is generally online homework. We have access to a really excellent virtual learning environment called integralmaths.org, which has loads of really good videos, loads of good exercises, and sets homework on there for you as well, right? So there will be, generally speaking, one piece of homework, maybe about, I would say around about 1 hour-ish per week. But on top of that, if you want to be like really, if you really want to be like doing really well with that, on top of that, that's just like the bare minimum. On top of that, you're going to be reading your notes after every lesson, doing additional exercises every lesson, right? I mean, at the end of the day, it's like, you decide what grade you're going for. This is another part of like being independent, isn't it? Right? If you're like, if you want to get an A star, you're going to have to put the work in, right? You're going to have to do a lot more than just the minimum homework requirement. You're going to have to be a self-starter and say, I'm doing that little bit extra. I'm going to have to do it because this is what I want. Yeah, but around about an hour of homework a week, plus you've got to do a good bit more to make sure that you are understanding everything from the lessons, because it takes a little bit to get your head around everything. Right, okay. I mean, Ruhan, would you want to say anything about like homework and like how, would you want to say anything about how the year's been and everything like that? Or like if you wanted to, like, you know, the amount of work you did, what sort of work you did through the year to make sure you were successful?
Yeah, sure. So for homework, we usually use a website called Integral Maths. So every homework or most of the homework is set in there. And because there was most of the year was lockdown, we had to make sure to complete those assessments on the website to boost up our grades at the end of the year. But that also helps you getting prepared for the exam, because there are different levels of exercises in the website. So it starts from exercise level 1 to level 2 to a final assessment, which really gets you prepared and lets you understand the topic. And as you go further in the year, you like the teachers will set different homeworks for the topics you just done in class.
Thanks, Ruhan. That's brilliant. So I think you could hear, like, you could hear what I was saying in that as well. That there is a sort of minimum requirement. Plus, there's like, right, okay, there's all this extra stuff there. And the good thing is, it's all there in one place, ready for you to do. There's no sort of excuse like, oh, I can't find any work to do. There's loads of good stuff, and we can help you with that, right? Are we going to have complex algebra like binomial expansion and Pascal's triangle? Yes. The answer to that question is yes. And those are really cool topics, so I hope you're looking forward to those. Okay?
Yeah, sorry, David. I think I asked the question about how to prepare before resumption. And I think that's a very vital question to ask, because I want you to understand that, you know, for you to be actually successful at A-level maths, your algebraic skills are quite important. I'm not saying other skills are not important, but algebraic skills are, you know, fundamental. So my suggestion would be to revisit the skills that you've been taught in secondary school, especially the grade 7 to 9 skills, possibly, and including those ones that were not even covered during school term. You know, it would be very, I mean, there are a lot of websites available that you could visit. You could look at YouTube videos, you know, and that would help greatly and prepare you for the start of A-level.
Absolutely. Things like certain indices, things like factorizing quadratics, things like completing the square. That's where we want you walking in the door being like, boom, give me any quadratic, I can complete the square. Give me any quadratic, I can factorize it. Give me any quadratic, I can sketch it. All right. Elizabeth wants to know, what kind of facilities are around the campus for studying and recreation? Loads of awesome stuff. We've got amazing sports facilities. We've got a gym. We've got a massive big basketball arena thing and everything. All this amazing sports stuff. A couple of years ago, we had a new library facility built, which is on 3 floors, 4 floors. If you go up to the top floor is the best one. That's like the silent study area. And it's also got these amazing panoramic views of London. Beautiful, an excellent place to go and study. Absolutely brilliant. Loads of facilities. I can't mention how many great facilities that we've got. One good thing is we are a very large college, a college of 2,400 students. It means we can offer a really wide range of extracurricular activities for you guys. And you'll see there's loads of awesome stuff. What universities are we linked to? One of the top universities we're linked to is Wadham College, the college at Oxford. I went recently to Wadham College with a trip with students. It wasn't this year, unfortunately. It was like the year before, well, 2 years previously, actually. But we usually go every year. What really struck me about what was going on at Wadham, they had us meeting 4 students, and every one of those 4 students was from Newham, just like you. And it made me go like, yes, we can get these students into Oxford and Cambridge. And we have been doing that. By the way, we get students into Oxford and Cambridge every single year. And we're super proud of that, right? No worries. Right, okay. Oh, adding on to the question, what statistics and how come it has its own subject? Well, I love that question. Statistics, just like any other, there's maths in itself. Maths as a subject is absolutely huge, right? You're only just scratching the surface of it when you come in to do your A-levels with us. You're absolutely just scratching the surface, the tip of the iceberg, right? And it's the same with statistics. You could do a whole A-level and you could do a whole degree doing statistics, and then even further. Same with maths and all these different ways you can go. We've got a statistics A-level because it's such a vital subject in itself. You'll understand, you'll see a lot of talk these days about how data is used, about people called specifically data scientists. Data scientists use statistics. They bring that together with things like computer science because the world is so full of data these days. You know about Google, you know about Facebook, you know about how every single thing you do online is recorded and every single thing is a piece of data, and data is valuable. So we need good statisticians. That's why there's a statistics A-level. Maybe. I don't know. Who's next? Right. Yeah, all right. Simon was asking something. What are Pascals? Pascal's this awesome French mathematician guy who invented this thing called Pascal's triangle. You can read about him. Look him up. How can we prepare before? Oh yeah, we answered that one, didn't we? Do we do any maths investigations? Boom. Yes. Guess what? We do a maths club. Maths club, right? You want to get involved in doing competitions. If you've ever done UKMT, we do that. I love those UKMT questions. If you've done the secondary one, we do the one for A-level students as well. It's even tougher and crazier and more mind-bending. Absolutely amazing, right? We get you, if you're interested in going, like somebody was saying previously, doing a maths degree. Say if you wanted to do a maths degree at Oxford and Cambridge, you've got to get yourself ready for the STEP exams. STEP exams is the entrance exams for going into Oxford and Cambridge. Some of my favourite questions, maths questions out there, are those sort of questions. You want to come and do those? Yes, we can. Those are all like doing maths investigations, to be honest with you. Right. Will there be weekly tests? Yes. Right, okay. Okay. Any upcoming competitions? Yeah, UKMT. We also do one called Right Angle, which is run by the MEI. We also do the UKMT Team Maths Challenge. Hopefully that will be running this year, lockdown permitting. That's a really amazing one. We go to Queen Mary University, take 4 of our best students to Queen Mary University, compete against all these amazing places, private schools, very selective schools, and we are always up there at the top as well because we get you trained up and ready for that as well. Okay. Right, Dr. Frost, any other questions that I've missed? Fantastic. Ori's added some fantastic questions up there. Doing things like math up, doing things like physics and maths tutor is what you want to do. If you're if you want to talk the talk about being some A-star maths student, right? You've got to walk the walk as well, which means getting the work done, right? We're really, really, really looking forward to seeing all of you next year. I hope this has given you a good idea of what the maths department here is like, what it's like doing maths, how passionate we are about what we do, right? It's not just me, it's the rest of them as well. They're all like this, everybody. So I hope you've had a good time, right? Any words from any of you guys before we go?
Yeah, just like someone was asking which websites to use before you start, and I've put some links there. So if you, someone amongst the students actually said Maths Genie will be a good start, especially for the grades 7, 8, and 9 for GCSE. And then after that, there is a Math Up website that you can use. It had arranged all the AS topics there. That is the first year of A-level, if you want to have a go before you start. Good luck, everyone.
Yeah. Question from someone. I'm not sure if this meeting's been recorded. I wasn't recording it myself, so I'm not sure if it's going to be online afterwards.
It is recorded.
Is it recording? Oh, it is recording. Right. I'm not sure where that's going to be. If you email advice@newvic.ac.uk, they'll be able to tell you. Okay, they will tell you. I don't know. Right. Okay. Brilliant. I think we've got to go because I think we've overran. But I had a really good time.
Yeah. Thank you. Bye-bye.
Thanks so much to Ruhan for joining us. Thanks so much to all the maths teachers here. Thanks to
Thank you, guys. Thanks for joining.
so much to you guys for being so amazing and getting some amazing answers out there. Brilliant. Thanks. Yeah, brilliant. No worries. Thanks, Ayat. Thank you, you guys. Brilliant. Great working with you today.
All right. Hope to see you soon.